All right, today we're tackling a massive question right at the heart of AI. We've all seen this incredible explosion in what AI can do. But what if the very foundation of this whole revolution has a critical hidden flaw? Let's dive into the quest to dethrone the king of modern AI, the Transformer. And yeah, I know, that sounds a little dramatic, right? I mean, we see models like GPT-4 and Claude 3.5 getting smarter seemingly every single week. But behind the scenes, there's a real and growing concern that we are pushing the current technology to its absolute breaking point. So the core problem is this. It's a kind of computational traffic jam. As we try to feed these AI models more and more information, like longer articles, entire books, huge chunks of code, the amount of work it takes to process it all doesn't just go up, it explodes. This is all because of something called quadratic scaling. And, well, it's a recipe for hitting a very hard and very expensive wall. And that right there is the multi-trillion-dollar question that researchers are absolutely racing to answer. If the way we're doing things now just isn't sustainable for what we want to do next, what's the next great architectural breakthrough going to be? Okay, so the technology we've been talking about is the Transformer. Ever since it showed up back in 2017, it has completely taken over the world of AI. Its superpower is this unbelievable ability to understand context, but its fatal flaw? That crippling, brutal inefficiency. The secret to the Transformer's power is a mechanism called self-attention. It's the magic trick that lets the model figure out that in a sentence like, "The robot picked up the ball because it was heavy," the word "it" refers to the ball. To pull this off, every single word essentially has a little conversation with every other word in the text to figure out how they all relate. And that's exactly where the trouble starts. You see, more words means way, way more of these conversations. This explosion is what the experts call quadratic complexity, or ON squared. To make that feel a bit more real, let's try an analogy. Imagine you're at a pretty small party, and to be polite, everyone has to greet everyone else exactly one time. With 10 people in the room, how many greetings do you think that is? It's 45. Okay, that's totally manageable. A little bit of mingling, sure. But you can get it done. The party works. But now let's just 10x the guest list. We invite 100 people. How many greetings do we have now? I'll give you a hint. It is not 450. It's a lot more. It's almost 5,000. The party just grinds to a halt. It becomes a total mess of just saying hello. And that is the exact problem Transformers face. Every new word or guest makes the amount of work skyrocket. So this chart shows you the math. The Transformer is O of n squared. That's our party problem. But these new architectures, like Mamba, which is something called a state space model, scale so much more gracefully. This is the difference between a system that works and one that just melts down. This massive inefficiency has kicked off a revolution inside the AI revolution. A whole new wave of challengers has appeared, all designed to slay that quadratic scaling dragon. And these challengers pretty much fall into three main families. You've got some that try to fix attention by making it sparse, fewer, smarter conversations. You have others that are bringing back an older idea called recurrent neural networks, or RNNs, which process information in order, one bit at a time. And then you've got the wild card, state space models, a radical new idea borrowed from a totally different field. So first up is sparse attention. The idea here is pretty simple. Not every word really needs to talk to every other word. So models like Longformer create a sliding window where a word only pays attention to its neighbors plus a few really important words. It's like having a quiet chat with the folks next to you at the party and only shouting across the room to say hi to the host. It's a really smart trade-off. Next up, linear RNNs. Now this is a completely different philosophy. Instead of processing the whole text at once, an RNN reads it one word at a time, kind of like we do. It keeps this compressed memory of everything it's already seen. The real magic here is that adding a new word costs the same amount of effort every time. It doesn't explode. And that makes them unbelievably efficient. So much so that models like RWKV7 are making this classic approach a serious contender all over again. And then we have the one everyone's talking about, state space models, or SSMs, with the star player being Mamba. This is a fascinating new way of thinking that comes from control theory, and what makes it so powerful is that it's kind of a shapeshifter. When it's training, it can scan all the info in parallel, just like a fast transformer. But when it's running, it acts like one of those super efficient RNNs. It's basically the best of both worlds. So we have the reigning champ, the Transformer, and these three powerful new challengers. But what if the winner isn't just one of them? The latest and maybe the most exciting trend in AI right now is making hybrids. The idea is, if you can't beat them, join them. A really popular way to do this is called the striped hybrid. Picture it like a layer cake. You start with a layer of that powerful but expensive transformer attention to focus on the fine-grained details. Then, you follow it up with a super efficient SSM layer, like Mamba, to summarize that info and carry it forward. You just keep alternating these layers, getting the pure power of one and the amazing efficiency of the other. It's a really clever design. And the results? They're just stunning. Take Jamba, a well-known hybrid model. It achieves 3 times the speed, the throughput of a similar-sized transformer, all while using way, way less memory. These aren't just tiny gains on a chart. This is a massive real-world advantage in both speed and cost. So all this brings us back to the big question. Are we stepping into a totally new era of AI architecture? Is the long reign of the pure transformer finally coming to an end? Well, let's look at the scoreboard. When we look at the smaller models, the kind you might actually run on your own device, the challengers aren't just keeping up anymore. They're actually winning. I mean, look at this. You can see the RWKV7 model, which is an RNN, outperforming a top-of-the-line transformer on multiple reasoning tests. This is a huge, huge deal. However, and this is a really big however, it's not a complete takeover. When you get to the absolute cutting edge, the biggest, most powerful models like GPT-4o or Claude 3.5 Sonnet, where cost is basically no object, the raw brute force power of full self-attention still reigns supreme. It turns out that when you can afford that chaotic 5,000 greeting party, it's still the most informed party you can have. So the real takeaway here is this. The future of AI isn't going to be a kingdom with one ruler. It's going to be a diverse ecosystem. We're moving away from a world where the transformer is the one-size-fits-all hammer for every problem, and we're moving toward a world where we pick the right specialized tool for the right job. And this really leaves us with a final and pretty exciting thought. Instead of one giant, slow, expensive model trying to do everything, just imagine having hyper-efficient models on your phone, lightning-fast models analyzing medical data, and incredibly robust models built just for scientific discovery. The end of the transformer's singular reign might not be an ending at all. It might just be the beginning of a much more specialized, accessible, and powerful AI revolution. And you have to wonder, what problems are we going to solve when we have the perfect AI for every job?